Good morning, math lovers. Today we are going to prove Pythagoras theorem. So what did Pythagoras say? He said that in a right angle triangle, the square described on the hypotenuse is equal to the sum of the square described on the other two sides. So what are we given? We are given a right angle triangle ABC, which is right angled at A. And then what is to be proved? It is to be proved that the square described on the hypotenuse, that means this BC is the hypotenuse, so the square described on BC is BCED is equal to the sum of the square described on other two sides. That means other two sides are AC and AB, so the square described on AC is ACFG and the square described on AB is ABIH. So the sum of these two squares should be equal to this bigger square. So now we have to construct something to prove our point. So we have to make the squares on BC. So we have to we have made this square, we have made again this square, and we have made this square. The square BCED, ABIH and ACFG on side BC, AB and AC respectively are drawn. Then we'll join AD and CI. That means we'll join AD and CI. Then align align AK parallel to BD. So this line is parallel to BD, is drawn cutting BC. So it cut BC at J and it cut DE at K. So this much is our construction. Now let's jump to prove the Pythagoras theorem. So we have the geometric proof. To prove the Pythagoras theorem, we have 14 statements backed by the regions, and finally we'll be able to prove the Pythagoras theorem. So let's move to the first point. The first point is that CAH is a straight line. Why? Because CAB is 90 degree and BAH is also 90 degree, because that is the angle of square ABIH. So both these angles add up to 180 degree, and 180 degree means straight line. Then comes point 2, that is rectangle BDKJ equals to 2 times triangle BAD. That is because they are on the same base BD and between the same parallels BD and AK. Then comes 3. In 3, square ABIH is equal to 2 times triangle BIC. This is also because of the same reason, that is they are on the same base BI and between the same parallels BI and CH. In point 4, we have angle ABI equals angle DBC. That's because they are the right angles of squares. Point 5, angle ABI plus angle ABC equals angle DBC plus angle ABC. That's because adding angle ABC to each side in our point 4. Then come to point 6. In point 6, angle IBC equals to angle ABD. That's because we are combining angles from point 5. That means this both becomes this and this both becomes this. Then in point 7, so in point 7 we have two triangles, that is triangle BIC and triangle BAD. So in these two triangles we have BI equals to BA. That is because sides of the square ABIH are equal. Then sub point 7.2, that is BC equals to BD. That is because of the similar reason, that is the side of the square BCED are equal. Then 3 sub point 3, that is angle IBC equals to angle ABD. So this is already proved in our point 6, angle IBC equals to angle ABD. So now point 8. So point 8 is that triangle BIC is congruent to triangle BAD. So that is because of SAS, side angle side rule from point 7. Then comes point 9. So in point 9 we have triangle BIC equals to triangle BAD in area. That is because both are congruent triangles, and if they both are congruent triangles, then their area will be the same from point 8. Then comes point 10. So in point 10, square ABIH equals to rectangle BDKJ. That now this is because from 2, 3 and 9. So from 2 it is given the rectangle BDKJ equals to 2 times BAD. In 3 it was given that square ABIH is equals to 2 times BIC. And in 9 we already proved that BIC is BAD. So BIC is BAD. So if these are equal, then this is also equal. So we can say that square ABIH equals to rectangle BDKJ. Now comes point 11. Square ACFG equals to rectangle JKEC by joining AE and BF. So why is this? Because of the similar reason from 1 to 10. So we have proved square ABIH equals to rectangle BDKJ in with the same construction and everything else. We can also prove this same thing because this is also same. So by joining AE and BF we can prove that square ACFG equals to rectangle JKEC. Then comes point 12, that is rectangle BDKJ plus rectangle JKEC equals to square ABIH plus square ACFG by joining these 2 points. Then comes point 13. So in point 13, square BCED equals to square ABIH plus square ACFG. That is because we combine both rectangles to form square from 12. That means this rectangle BDKJ plus rectangle JKEC, this both if you combine it will form square BCED. Then comes 14 point. So in 14th and the final point we have already proved that square BCD. So what is square BCD? Square BCD is BC square. What is square ABIH? Square ABIH is CA square. And what is square ACFG? Square ACFG is AB square. So area of square is its side squared from 13. So hence we have proved Pythagoras theorem. Friends, if you think that you have understood it well and you like this video, you can subscribe me, because I will be bringing many more proofs about the Pythagoras theorem, because the Pythagoras theorem can be proved in many different ways. So I will be bringing more ways to prove Pythagoras theorem. So you can just subscribe my channel, and many more videos, knowledgeable videos will be coming in the days to come. Thank you.